I started a video, somebody called me in the middle of it, and apparently it cuts your video off, so I want to try again. Solving quadratic equations by factoring. And what that means is we are going to factor a quadratic equation to determine where that quadratic, that parabola, intersects the x-axis. So parabolas we know open up when the a value is positive. They open down when a values are negative. It doesn't matter if they open up or down. They can have 2 points on the x-axis, and that would indicate 2 solutions, because by definition to solve means that we're finding where the parabola crosses the x-axis. So in other words, we're going to factor today to determine what these 2 numbers are. You can have 2 solutions. You can also have an example where your parabola opens up, and again that can open down as well, but it sits on the x-axis. So this one has 1 solution. And then the third type of solutions we can have is if your parabola never touches the x-axis at all, never crosses it, so this is no solution. So we can determine what these values are by factoring. If it's not factorable, then that means there's probably no solution, or that simply means that we need to find a different method to solving. And there are several other methods out there to solving. You've got factoring, you've got the quadratic formula, you've got completing the square, and you've got graphing. And you can use tools like Desmos, you can use a graphing calculator to find those values. But for today, we're going to look at how to solve them by factoring. So today, we're going to probably end up with 2 solutions for most of ours. We might find an example that gives us 1 solution. But we won't have any today that have no solution, because we are going to be able to factor each of these that I'm going to do today. Okay, and please know that these points here are called Xintercepts. This is super important because every textbook, worksheet, quiz, test, internet source, they call them different things. So you can call them Xintercepts, you can call them roots. Think about a tree. This is the ground. The roots start here, so that's why maybe they call them roots. Zeros, they're called zeros because your y value is a 0. Let's see here, or solutions. So just know if you see one of these 4 words and they're asking you to solve it, this is what they're looking for. The Xintercepts, the roots, zeros, or solutions. They all mean the same thing. Remember, we can only have 2, 1, or none. There is no way to get 4 solutions, 3 solutions, 5 solutions, something like that. Not with parabolas. Okay, so to solve by factoring. Solve by factoring. What we're going to do, first thing, is you got to get the equation equal to 0. Whoops. Get the equation equal to 0. So put everything on one side, put a 0 on that side by itself. That has nothing there. Then you're going to factor. And you can factor out the greatest common factor. You may have difference of squares, or you may just need to do bottoms up. That's a trinomial. So GCF, difference of squares, that would be if you had a binomial. This is terrible handwriting here. Bottoms up we use when we have a trinomial. All right, then after you've set your equation equal to 0, you factored it using one of these 3 methods, then you will split your factors up. I'm going to show you what that looks like. I say split and solve. All right, and those are your steps to solving by factoring. So let's jump into an example. And let's do 2x squared minus 11x equals 40. All right, so your instructions are going to say to solve. 1, I know it's going to be a solving problem because it's an equation. We solve equations, we simplify expressions. So there's an equal sign, so I know I have to solve this. So step 1 is to set the equation equal to 0. To do that, we're going to move that 40 over. And it's very important when you set these things equal to 0 that you leave your equation in standard form. You should know what standard form is. That is the x squared term, followed by the x term, followed by the constant term. So when I move this 40 over, it's going to go on the end because it's the constant. And because I'm moving it over the equal sign, you simply change the sign. It was positive, now it's negative. That's because we're subtracting it to the other side. All right, so 2x squared minus 11x minus 40. The first thing you always want to ask yourself, is there a greatest common factor? And the answer here is no. Is this difference of squares? Definitely not. That works with binomials only. So now we're going to ask ourselves, trinomial, yes, it has 3 terms. So we're going to do that bottoms up method. And I did a video to review bottoms up. You might want to go back and watch that video because I'm just going to breeze through this quickly. Multiply the first and last gives you negative 80. Trying to find an 11. So I could list all my factors, or I can just think and say 15 times 6, or 5 times 16 is going to give me 80, and that also subtracts to give me my 11. So set up my 2 houses. Got to figure out my signs. The 11 is negative, so my 16 is bigger, so it will match that sign. Divide by the leading coefficient. Again, this is how you factor using bottoms up. Multiply the first and last. It helps if you list all your factors so you can see them. Okay, I could have said 1 and 80, 2 and 40, 4 and 20, 5 and 16, 8 and 10. I think that's all of them. Find the one that gives you 11. So 5 and 16 gives me my 11. Positive 5, negative 16. Divide by that leading coefficient. Reduce if you can. This is not reducible, so I bring my bottom up. Reduces. All right, so I am done factoring. I have set equal to 0. I have factored. Now my last step is to split this and solve it. What does that mean? That means I'm literally going to draw a line here to split up my factors. Kind of creates 2 problems here. So set them both equal to 0 and solve each equation. So this left side, 2x plus 5 equals 0, I'm going to move the 5 over. So that becomes negative 5 equals 2x. And then to solve, you're going to divide by 2. That's just solving a basic equation. Box that up, that's one of my solutions. The second equation, you're going to move your 8 over, so it becomes x equals 8. And that's all there is to that one. So what does that mean? That means I have a parabola, 1, 2, 3, 4, 5, 6, 7, 8, that has an x-intercept at 8 and at negative 1, 2.5. So I could figure out where my vertex is. Ooh, that is terrible drawing. I hit my little stand here and it made it wonky, but you get the idea. So I could definitely graph that on a calculator. Let me show you what that looks like because my graph is terrible looking. So if I go in here, get rid of all this other mess, 2x squared minus 11x minus 40. And if I graph it, you can see that it touches at negative 2.5 and it touches again at positive 8. So those are my roots. That's my solution. Pretty cool. So that is how you solve a quadratic by factoring. And I'm going to show you another example. So let me slide this up. Excuse me. 4x squared equals 16. Again, I know it's a quadratic because of the x squared. As long as you have an x squared, you know you're solving a quadratic. If that x squared wasn't there, then I would just simply divide by 4 and be done. But it's a quadratic, so we're going to follow the steps. Step 1 is to set it equal to 0, so I'm going to move that 16 over. 4x squared minus 16 equals 0 now. Then I'm going to factor. If I notice, I do have a greatest common factor. 4 and 16, I can divide by 4. So when I divide by 4, I get x squared minus 4 equals 0. And I can factor this again. This is inside the parentheses is called, that's right, difference of squares. So keep your 4, and then you've got x plus 2, x minus 2. So we did GCF, and then we did difference of squares. So again, we are solving by factoring. And there's probably a different method I could have done here, but I want to solve by factoring today. All right, so I'm going to slide this down, so I think I'm going to run out of paper. I'm ready to split and solve. So everywhere you see parentheses, you're going to draw a line. So I've got 1, 2, 3 factors that I need to set equal to 0. Well, the first one makes no sense. If I say 4 equals 0, throw it out. That makes no sense. This middle factor, we have x plus 2 equals 0. So when I solve this, I end up with x equals negative 2. That's a good answer. X minus 2 equals 0. When I solve this equation, I get x equals 2. So this quadratic equation I started out with, remember I set it equal to 0, and then I factored it because I noticed it had a greatest common factor, so I divided by that first. And then it left me with difference of squares that I could factor. Then I could split and solve. So my solution is negative 2 and positive 2. So be careful when you're factoring. Sometimes you have to factor out the GCF and then you can do bottoms up or difference of squares. So just take a look at the problem carefully to make sure you factored it completely. It makes it a lot easier to solve when you factor it completely. And that is all for solving quadratics by factoring. Make sure you know how to factor using greatest common factor, difference of squares, and the bottoms up method. If you need a refresher on how to factor using the bottoms up method, because I went through this problem kind of quick, I do have another tutorial video. It's called Factoring Trinomials. You can go back and watch that. But the only thing different about solving versus just factoring, solving you have to go back and do the split and solve, where you divide up your problem after you factored it and you set it equal to 0 and solve it. So there's just one extra step to solving a quadratic by factoring, split and solve. So please make sure you know the difference if the question asks you just to factor or to solve. Make sure you know how far to take that problem. And that's all I have for you. I hope that was helpful, and see you next time. Bye.